Without performing any calculations, which of the following data sets has the smallest standard deviation? So we have to understand intuitively what a standard deviation represents. And remember, a standard deviation is just the typical or average distance from the mean of the data set. So if we look at each of these things, now we can't come up with the exact mean of these things, but we can kind of estimate where we think the mean might be. Like here, set 1 would be there, 2 would be like right here, here would be up here, maybe a little bit. Yeah, that's fine. And 4, it would be like right around here. Now what we're doing is we're looking at the deviations, how far all these points are from the mean. And on average, which one seems to be more spread out away from the mean. So we're just kind of looking at these distances. For example, right here, we see this point has a deviation about that far. And we're looking at each of these deviations and seeing how far away they are from the mean. Well, in this first one, and even the third one, they look about maybe equally spread out. Maybe the set 3 is a little bit more spread out. Set 2 seems to be very spread out. These points go way far away from the mean. They're very spread out away from the mean. And then set 4 seems like everything is very, very, very close to the mean. So set 4 is very close to the mean. So if we're using our standard deviation to measure the average distance, well, on average, set 4 is very close to the mean. Set 2 is very far from the mean. And 1 and 3 are kind of in between those. So being very close to the mean is going to give us a small standard deviation. The distance is going to be smaller on average. So that one would be our answer. Now, if this had asked which one's the largest, then clearly set 2 would be the largest, because this one on average is farthest spread out away from the mean.